So just after you get comfortable finally with limiting reagents and converting reactants to products and that sort of thing, we move on. But that's how these general anything course is. I mean, you're going to have a lot of material. So, but this is interesting. Predicting whether something is going to dissolve in water or not. That's really what we're at today. Will it completely dissolve? Is it completely soluble or not? But the more interesting question to me is the stuff that doesn't dissolve. Because like the Twinkie, I mean, look at that thing. It's disgusting, but it's interesting in its own sort of way. We had a research project, and ever since, I don't know if you know about the Little Froggies in Minnesota, but maybe 10 years ago, I'm from Minnesota, so the Little Froggies were growing like 5 legs, and it was really kind of some weird stuff was going on. But then articles were coming out that, and I didn't know this, that if you take Tylenol, if you take, I don't know, if you have diabetes, a lot of people in San Antonio have diabetes, they take clofiberic acid or naproxen, that sort of thing. But anyway, no matter what drug you intake, your body only metabolizes about 5%. So that means over 90% you're just whiz away, right? Where does it go? It goes to our sewage treatment plant. So, and this stuff is just building up in the environment because it doesn't dissolve, it stays in the water. So one of the research projects was we took the influent, what's going into the sewage treatment plant and what's going out, and just analyzed the water. And you can see the organic compounds, a lot of it didn't even change. And we did. We found Tylenol, acetaminophen, in the influent and the effluent, and we found naproxen too. So it's like these little fishies say, man, it's a real problem in our environment. These drugs, these compounds that people take, they're just building up in our lakes and streams, and we're just not so sure what to do about it. Okay, so we're talking about ionic solids. So if you dissolve an ionic solid in water, it would look like this. So here's our ionic solid, and here's our water molecule flying around, right? You see the H2O. And let's see if it grabs one off here. There's something's happening. See how the oxygens are all oriented differently. So that must be a sodium ion, because oxygen has kind of a little negative charge. And we'll see that later, I think, next semester or something. These have a little bit of a positive charge. So they orient themselves differently around the different ions. So that's pulling off a sodium ion. Here these guys are pulling off a chloride anion. We'll go a little bit further there. See how the H's are oriented around it, around something negative. So that's what it's looking like. They believe that's what it looks like, and I mean, there's no reason to see why they're wrong. But that's dissolving, that's soluble. So this happens for something that's completely soluble. Okay? So a little review here. Potassium phosphate. So how do you write these ionic compounds? Potassium has a what charge? Do you remember? A plus 1. Right? They always write the cation first. It's always plus something. Phosphate had a negative 3. Right? Negative 3. And remember what you do with the charges? You move them down. Right? Cross them. So we'll have 3 of those and 1 of those. Now what does that actually mean? That means that, what is this crystal composed of? It's composed of potassium ions, if you're going to break it up, and phosphate anions. But how many of these potassium ions? There's 3 of them. So where do you put the 3? In front of it is the coefficient, stoichiometric coefficient. Okay, so just to review on how we break up these ions. AQ or S. We need to write AQ or S on these compounds. Annabelle, what is this AQ or S stuff, subscripts?
AQ is for like a liquid.
Yeah, well, kind of not really a liquid. It goes into the liquid. It goes into the water. It means it's soluble. It's soluble. It dissolves. That's the AQ one. S is for the solid. It stays a solid, doesn't break up. Okay, very good. So, for example, we have sodium sulfate. I know that's AQ. Calcium hydroxide, I don't remember. So what we're getting at is these are solubility rules. Oh, we're going to do it. We're going to do it. Okay? So how do I know that? How do we figure this out? What subscript we put on? I'm not going to give you this table. I'm going to show you what I'm going to give you later. The next page I'm going to show you what I'm going to give you on all the exams and quizzes. But here's all of our polyatomic ions just for review. No big deal. Okay? But here's our rules. And this I give you, our solubility rules. So is calcium chloride soluble or insoluble? Now when we're playing this game, right, soluble meant, right, what? AQ or S? AQ. Insoluble meant, right, S. Okay, so calcium chloride, which one do you write? Pretty much if you look on here, they're organized, everything is organized by the anion. So you just got to find chloride. Do you see it in the rules? Right here. All right? So you'd like to write AQ on it. Well, before you start writing AQ, check the exceptions. Right? Because chloride, you should almost always write AQ. Is calcium an exception? Nope. So you write AQ. So you should always check those exceptions, because otherwise they're going to bite you in the back if you don't. Okay. Calcium chloride is AQ. How about, there's calcium hydroxide, the one that I forgot. Calcium hydroxide. AQ or S? Let's see if Allison's reading this table right. Calcium hydroxide, Allison. Here it is. I'm ready to write a solid on it, but she's right. She's right. There it is. So you should write AQ. Man, I would have guessed wrong. Almost all these hydroxides are solids. So here's hydroxide and all of its exceptions. Okay? So you should write an S on it, because that's what it says, but check the exceptions first. And there it is. So you better write AQ. Does that make sense? Okay. Look at all these alkali metal ions on the exception side. What the heck are these? That group name.
1 and 2.
Group which A? It's just group 1A. That's group 1A, all those alkali metal ions. Okay. So when you'll get used to using this table. I mean, for example, you won't start looking at it after a while. Like, you'll see nitrate a lot. And look, there's no exceptions. So whenever you see nitrate, you're always going to write AQ on it, because there's no exceptions for it. So that kind of thing you'll get used to. But okay, so what do I give you? I give you this. Here's your exam 2 handout. So for all the quizzes up through exam 2 and exam 2 itself, this is the handout you get. And some reactions. We just haven't got there yet. Okay? But notice how I don't see a percent yield equation on there. So that's one that I'm going to expect you to know then. All right? Percent yield was the actual over the theoretical times 100, right? So if it's not on here, you're going to need to know it. Okay. So let's try a few of these. So what I want us to do is we're going to go to the boards for a little bit, but I want to show you what I want you to do first. And then we're going to come back and wrap this up. Are these compounds water soluble? If so, write the ions that will be present in water. So we need to write a little subscript on these. And if you end up writing AQ, you have to break it up into its ions. If you write solid S, just quit. I mean, it's a solid. It doesn't break up into its ions. Okay, so potassium nitrate. AQ, right? Is that exception? Nitrate. I mean, there are no exceptions for it. So AQ. So definitely break it up. Now, I'm kind of going too fast here. I strongly suggest writing the charges on these things, because your life is going to be so much easier in the next part. Right? strongly suggest writing the charges before you even start. So that means it's going to break up into a K+, and it's going to break up into a nitrate. So whatever ions you wrote here, you have to write over here. And then you just got to figure out how many of them. And there's just one of each, right? There's a 1 here, and there's a 1 down there. So there's one of each. Okay? So let's just do one more. Lithium carbonate. Is that a solid, Oscar, or AQ? Lithium carbonate. Lithium carbonate. It's on the insoluble side. Should be an S, but look at the exceptions. Oh, those alkali metals.
So then it would be aqueous.
Yeah, it's aqueous. Okay. It's aqueous. So, Melissa, what ions are on here? Like lithium, what charge do I put on here for lithium? 1. Good. She looked at the periodic table. That's what I want her to do, right? Carbonate. What charge do you put on the carbonate, Daisy? Now you have a cheat sheet. It's a -2, right? Now you have a cheat sheet because this is available to you. If you, carbonate with CO3, what's the charge? Just look, there it is. Okay, -2. Okay, so breaking this up, what would you write, Danielle? Two lithiums. How do I write the charge? Right up here, right? And then CO3 with a -2. And how many of them? How many of these guys? Just 1, right? There's a 1 there. So just 1 carbonate. I kind of think of the molar mass thing. If I was going to find the molar mass of lithium carbonate, right, you'd find 2 lithiums added up on the periodic table, and then 1 of these carbonates, a carbon and 3 oxygens. Yeah, sir. Carbonate, you're right. Carbonates, almost all of them are solids, except it has an alkali metal. So that means it's an exception. So that means you have to write AQ. Okay? Because alkali metals are an exception. So let's go to the boards and let's just go through and go work through G and stop. And then we'll come back and we'll do some more. So bring your solubility rules with you. Go through G. Whoops, sorry. Yeah, go through G. So start with E. Start with C and just go all the way through G. So determine whether it's soluble or insoluble first. Right? Write the ions on there. If it's AQ, break it up. If it's a solid, just go on to the next one, but write S on it. Go by this, Sarah. Right? You're right. See this? He's a 2. Good deal. But look at that solubility rules thing. Where's that solubility rules at? Right? Acetate. Where is it? It's there. It is. It has a -1. He's a -1. Okay. So that means whatever you write, if it's AQ, is it AQ or S? Let's see. Acetates. There's no exceptions. It's AQ. So that means you have to write an arrow, and then whatever you have to write the cation plus the anions. It has to be this guy plus all of that. And then make sure you write the right number of them.
Would it be just one?
Just one of those
And
and two of these, exactly. Okay, good. Oh, you're close. Realize this guy, he's in the solubility rules. He's got a -1 charge. So he's a negative. And he's always positive, he's always negative. But put him inside the parentheses, so it'll look better, because it means you have 2 acetates. Yeah, there you go. And don't forget your negative charge on your acetate.
Oh, yes. The 2, you have to put the 2 to the top here.
Yeah, so you need parentheses with a little subscript 2. So that means you have one of he needs a 2 on him.
Yeah.
You have one of these,
And then 2
but
of these.
there you go, and have your negative sign. Very good.
Do you have to break up each
Well,
one?
no. This
That
one,
stays
the
the
hint.
same.
Oh, you don't have you should have your solubility rules with you. All right, where's your
this is
little book?
together.
Yeah, that's all together. And then you're in the solubility rules, it lists him. He's got a negative. So this whole thing has to be written there with a
Okay, so
negative
it just
sign.
stays.
It all stays together. O2 with a negative sign. And you have 2 of them. So that 2, if you have 2 of them, there, it has to go up front. It means you have 2 of them.
Oh, okay.
Yeah. And you can write AQ on every single ion if you want, but it's kind of getting to be a bit much. So I don't write those. Okay. Good. Just don't forget to write your charge on there, because its acetate has a negative sign. Yeah, he's got a negative sign. Yep.
this one too?
Yeah, so I would write, before you even start, I would put a +2 here and a -1 there. So then it's easier to break up.
Okay.
Yeah, he'll be a +2 and he'll be 2 Cl minuses. Okay? So it helps if you write this. Good. I think everyone's got the first one here. So then you just stop. He doesn't break up into his ions.
Oh yeah, because
It's a solid.
Only if it's a
Only if it's AQ. Good. So he's a solid, so leave him alone. Good. And don't forget your minus sign. I think put the minus inside the parentheses, because it'll look better. Because that means you have 2 of these whole things. It's the opposite of where it was.
So for this one, it'll be solid though.
Yeah. Okay, chloride, they're all soluble except for the lead. So that means that makes it insoluble. That makes it solid. You're right.
Okay.
That makes him a solid.
Now what about this one?
Magnesium bromide. Where's bromide?
Bromide is right
Okay,
here.
so they're all soluble except for these guys. So, yeah, so they're all soluble. It's AQ. Because magnesium is not one of these.
So then we look on here, and then I see a +2.
That's why you put a
that,
2 on there.
And then the bromine is
It's -1.
Oh,
Because
negative
you count 1 over. He's -1. And the hint, remember you have all these anions over here. So
It already
there's
has.
bromide, Br minus.
Okay. So then I would only...
No, you're okay.
Oh, no. I was right. Like
You're
that.
right. Just have your charges, a negative and a +2.
Plus.
2. Right? Because he's +2.
Okay.
There you go.
But what about the subscript?
No, this means that there's 2 of these. That's what the 2 means. There's 2 bromides. So to represent 2 bromides, you have to put the 2 out front.
Okay. So what about... Oh wait, that's a solid.
Copper chloride is?
I don't know.
Let's check.
Yeah, that was two.
They're all soluble. Yeah, you're right. That's a solid too. Isn't that copper chloride a solid? Right? They're all soluble. Oh no, they're all soluble. You're right. They're all soluble. No, I made a mistake. Yeah. Because they're all soluble. They're all soluble. That means AQ. So you got to break him up.
Like those come together. That's like that.
Right? Good. Very good. Very good. Now, I wouldn't write solid. Write the compound with a subscript S on them.
Okay.
Will that help us for the next part?
But magnesium is.
Now, magnesium bromide.
But Br2 is.
Find bromide. Okay. They're all soluble. They're all AQ except for these guys. But magnesium isn't an exception. So it has to stay soluble, AQ. So he'll be AQ.
Oh yeah, it is. Yeah, that's.
So you getting more comfortable with this stuff?
What did I write first?
So,
Is this one?
so whatever you write over here, you wrote AQ, and this is great. You got the +2 and the -1. So whatever you write over here has to be this ion, and it has to be this ion, not the 2. That ion. And how do I know it's that ion? Because look, there's Br minus. There's no such thing as Br2 minus. So that means you have one of these, but you have 2 of these Br minuses. Yeah. There you go. Well, it's a +2. So don't forget to write these charges. Yeah, these charges are really nice. Oh, he's a -1. They're both 1s. Right? I is a -1. Oh, you have it right over there. This needs a plus here.
This one, this is.
Yeah, it's a 1. They're all 1s. Yep. Okay, so we're going to practice a lot more on that, just in a different way. So here is the majority of your homework right here. Let's talk about how to work this out. Okay. They're giving you aqueous solutions. It's always going to be aqueous because that's water. Everything's dissolved in water. That's the whole question. So that's okay. Aqueous solutions of these two compounds, calcium chloride and lead-2 nitrate. They're mixed. Okay, so they're going to be our reactants. And we're going to add them up. And write the balanced molecular, ionic, and net ionic equations. So molecular, we're going to write the reaction with AQ or S on everything. Ionic, if you see an AQ subscript, break them up. Net ionic, if you see the same ion on both sides, we'll cancel it. Like if you see an Na plus on both sides, we'll cancel it. So let me show you how this goes. Calcium chloride. Calcium. And write those darn charges. That's going to help you so much. Calcium has a what charge on it? +2. If you're not sure, use that periodic table. Chloride, that's Cl, has what charge, everybody? -1. Just count over to the nobles. And do the cross thing with the charges. There's my calcium chloride. Right? Plus lead-2 nitrate. So lead has to have what charge on it? A +2, lead-2. And nitrate, you just have to have it memorized. But now you've got that solubility rule thing. So if you forget what nitrate is, what's the charge on nitrate? Just look at the solubility rules, because nitrate's sitting there. Okay, move the charges. Okay, now how do you figure out the products? All you do is switch the cations with the anions. In other words, move calcium with lead's anion. So move the calcium with the nitrate, move the lead with the chloride. And by having those charges up there, life is so much easier. This is what I mean. Take the calcium, right? That's the calcium. Put it with the nitrate. Okay? And by putting those charges up there, it's so much easier, right? What to do, how to write the formula is staring at you. You got to move that too. Right? That's calcium nitrate. And then you move the lead. Right? It's always the cation first. You move the lead with the chloride. So that 2 has to go down there. Okay. Now, I always forget to balance, so I got to make sure that you are. Yeah, I'm balanced, right? I have 1 lead on both sides. I have 2 nitrates on both sides. It's balanced. So I usually forget to do that, but I didn't this time. Okay. Now we write AQ or S on everything. Calcium chloride. Chloride, everything's soluble, everything's AQ, and calcium's not an exception, so AQ. Lead nitrate, all nitrates, they're all AQ, always, right? No exceptions for nitrates. So might as well do the calcium nitrate while we're at it. The lead 2 chloride. Chloride, they're all soluble, they're all aqueous, but lead's the exception, except lead. So I better write an S. Okay. Now what I'm going to do is just break up everything that's AQ. Right? I'm nice and balanced, so I can move on to the next step. Break up everything that's AQ. So I'll break up the calcium chloride into its ions. Calcium, and how many chloride anions? 2 of them. And I better break up the lead 2 nitrate. Again, see how writing those charges just makes it so much easier, right? Lead 2 nitrate, I've got the lead 2, and I need 2 of those nitrates. So another habit I have is whenever I see a polyatomic ion, notice I use parentheses. It's so much easier to see the answer. Okay? Whenever I have polyatomic ions, I use parentheses, but you don't have to, but it's easier. Calcium, got to break him up because he's aqueous. And do not break up this one because he's solid. I mean, I'm not even going to bother putting the ions on because why? He doesn't break up. Okay. But you can, doesn't hurt. Now we have to cancel stuff. Does anything at all cancel? To get the net ionic. The nitrate's good. Calcium, looks like calcium does, right? Because calcium's over here and it's over there. So that's it. Everything that's left over, you just write it. That's the net ionic. That's it. So the hardest part, where all the work is writing that molecular equation. So spend a good amount of time writing that and get it right. Otherwise, you're just wasting your time with everything else. Right? So get that molecular equation right. So you write down, make sure you write the charges, switch the cations with the anions on the reactant side to get your products. Write AQ or S on everything to get the ionic. Break up everything that's AQ. Leave it alone if it's a solid. Net ionic. Right? Just everything that's remaining that didn't cancel out. Before I let you start working on this stuff here, when you write your molecular equation, is it possible to have a solid on the reactant side? Yeah. I mean, you could. You look at the rules, there could be a solid on the reactant side. And don't let it scare you. If you have a solid on the reactant side, you follow the rules. It can't break up. You don't write the solid on the ionic equation. If it doesn't cancel, you write the solid on the net ionic equation. It's no big deal. Solids are reactants. What if everything was AQ on the molecular equation? It's possible, right? If everything was AQ on the molecular equation, what would happen in the ionic equation? Everything would be an ion. What would happen on the net ionic equation? Everything would what? Everything would cancel out. So when you end up with AQ on everything on the molecular equation, you're supposed to write, and there's going to be one of them coming up, NR, which stands for no reaction. Okay, but that'll be coming up later. So you just, I would stay where you're at because there's so much to write. So write a molecular equation, write a ionic equation, and the net ionic equation.
So kind of like a no reaction, would it be like kind of mixing water and salt?
Yeah, you have to have AQ on both sides. Everything is AQ. So all your ions are going to end up canceling out when you write the net ionic equation. Yeah, actually, like sodium chloride on both sides. Sodium ions and chloride anions, they would cancel out. So try this one. And the in your book that you have, that handout, I would just tear it out because that's why it's there, right? This exam, I would tear it out because that's why it's there for you to. But I suggest not writing on it because then it treats everything like a quiz or an exam question, right? So use it as your cheat sheet, just like a periodic table. Okay, but try not to write on it. But all your rules are there, and everything I'm giving you on the test is there. So use that for all your homework, and you'll be most prepared for the exam. So I mean, you don't have to tear it out, but I would. Sodium sulfate and barium nitrate. And if you forget the charge on something like sulfate, just look at those solubility rules, because it's sitting there. If you're not sure where to start or how to do something, just ask. Good. And then this is really good, but that should be a negative, right? And then move that 2 there. You have a 2 there. You need a 2 down here for the nitrates. And these 2's are going to end up canceling, right? Just leave it as it is. Then make sure it's balanced. And I just got to do AQ or S's on. Oh, yeah, you balanced it. See? Good, very good. See, I really forgot to do that. I think that's all you got to do to balance it. Yeah, and I do AQ or S. Alejandro, notice something I didn't. This one you actually have to balance. There is something to balance in this one. Oh, yeah. Yeah, there's 2 trick questions in this one. See if you caught them. You're on something there, Christian. Right, so on that barium sulfate, those 2's, You just leave it as barium sulfate. You don't those twos are the simplest ratio. Yep. Yeah. And then Alejandro knows he had to balance it. To balance it, what'd you do? Put a 2 in front of the NaNO3. And that will balance it for you. I think that's all you need to do. Right. And then do AQ or S on everything. Make sure when you break up that sodium nitrate, you have a 2 in front of it. So you have to just distribute that 2. You should end up with 2 sodiums and 2 nitrates when you break up that sodium nitrate, because you have a 2 in front of it. Okay. If you got your final answer, go on and write the next one. See if you can write the molecular equation for the next one. If you got this one and you have a few minutes, see if you can do EX4. If you're not sure how I got this one, just ask. Oh, okay, this is one of those tricks. For molecules, you leave the subscripts there. But for all ionic compounds, whenever you have the cations and anions, it's always the simplest ratio because they're crystals.
Okay.
So you're right. There should be Ba2SO42, but they cancel out because it's the simplest ratio. Yeah, they always do that for ionic compounds. I minus. Iodide is I negative. Yeah? Everything's AQ. And everything in the molecular equation is AQ. Did that happen in B? Just get this guy down to. Really? You end up with AQ on everything for B, huh? Did you, Melissa? I don't think so. I think you're right, because I bet I threw one of those in here. Magnesium. And the sulfate. Potassium. The iodide. Go to magnesium. And the iodide. And potassium. And the sulfate. Ooh, we gotta balance him. Better put a 2 there. That looks good, right? AQs and S's. Magnesium sulfate is AQ, right? You got my AQs to this chart. Sulfate. Yeah, they're all soluble. And iodide. Yeah. So this is a good. B is an example of where everything is AQ. Right? So you could write a big NR and move on to the next one. Okay. So I scribbled out the molecular equation for C, and then you can check yourself. But there's a bunch on here, and we'll never get through all of them in an hour. There's just always extra. But come by. I'll be glad to help you out. Remember, asking questions, like they said yesterday, is a sign of intelligence. So come by and ask some questions. Have a good weekend.